My name is Niyi. I am the founder and managing director for Change Enablers Limited. It's a small boutique change management consultancy. My background, I'm a Lean Six Sigma Master Black Belt with about 20 years experience in the financial services and public services sector. I've worked with most of the banks, most of the European banks, Deutsche Bank, Credit Suisse, Barclays, RBS, and I've also worked with a number of public services. I'm also an academic, so I did my PhD in predictive process monitoring, but my research interests include causal process mining, which we'll be talking about later. Hand over to my co-presenter, Lukas, to introduce himself.
Thanks, Niyi. So my name is Lukas. I'm one of the co-founders and the CEO of Noreja. Before that, you will hear a lot about Noreja today in the first part of this webinar. Before my time at Noreja, I also worked in the academic field, did some research in the area of process mining, more on the managerial and organizational field. And before that, I worked as a consultant in the area of data and analytics, did a lot of projects when it comes to data transformation, ETL, data warehousing, and also did some projects with other process mining vendors at the time. Now very happy to be here, and Niyi, I will head over to you again.
Excellent, thank you. So over the course of the next 45 minutes, we'll be looking at causal process mining, why it's important, and we'll be looking at how Noreja creates a wonderful foundation for causal process mining. But let's first talk about what we mean by causal process mining. Let's define what we mean by causality. And it's very simple. This sits well with logic and common sense. Well, causality is when something, and that thing could be an event, a process, a state, an object, contributes to the production of another thing, another event, state, object, or it could be a problem. It's either wholly or fully responsible for it. So there are two concepts here: a cause, which influences the production of an effect. Let's illustrate that. So assuming we get a sales order at 10:53, and looking at our data, we notice that raw materials were ordered 5 minutes later. The question is, did we order this raw material because of the sales order we received? In other words, is there a causal relationship between event A and event B? And this is important because if for some reason there is a defect in the sales order, we have the wrong information, we're likely to see that cascade to event B. So we'll talk about how to understand the causal influence of one event or one relation to another thing. And that's what we'll be discussing over the course of this webinar, and how this Noreja as a process intelligence platform enables us to do that. Why is this important? Well, over the last few years, there's been an explosion in process mining. And for many of us who are involved in this field for many years, I've been involved in process mining for about 10 years as both a practitioner and a researcher. This is very heartening. And just to give a bit of background for those who perhaps are not as familiar with process mining, it involves using an event log, which typically contains a case ID, an activity, and timestamps, to discover typically the sequence of our process. That's just one of the things. You could also discover things like throughput time and so on and so forth. But in effect, you have your data from your source systems, your process aware systems, with a process discovery algorithm, and you discover what has happened in your process. This is often called descriptive process mining because it describes what has happened. But when you're examining what has happened, we often see undesired effects. So, for example, in this case, we notice rework. So we create an offer, the offer has been created, but almost 1 in 10 times that's been reworked. We have to create another offer. Obviously, that's a problem that results in loss of time, cost money. That's just one problem. You could have other problems like bottlenecks in your process, things taking too long, or if you have a deadline when you have to deliver by, missing your on-time delivery, so low on-time delivery rates or on-time delivery in full. What descriptive process mining algorithms do, though, is they tell you what has happened. So they tell you have a problem, but they typically can't tell you why that happened. And that is important because if you don't know why something happens, then it's very difficult to try and solve it. I'll illustrate that. So assuming we have a problem with on-time delivery, yeah. So this is what a typical process, a descriptive process mining dashboard looks like, yeah. So this has the on-time delivery as well as the delay for teams involved in the process, yeah. You also can see the number of cases each team has handled. Now, I'd like to take a moment to study this dashboard because just looking at this, it's clear that one team has significantly poorer performance than others. It's got it's got a worse on-time delivery rate and worse delay than other teams. Can you figure out which team that is? Well, no prizes if you say it's Team Hermes. If you look at the next worst performing team, Poseidon, its average delay is almost 3 times as many as that. Its on-time delivery rate is almost half the next worst team. So it's clear that cases that Team Hermes deal with are likely to be delayed and late. So there is a clear association between the team and the on-time delivery. What this dashboard doesn't show, though, is that there is a confounder. In other words, a third factor that's unseen, but which is driving this on-time delivery rate. So in other words, more complex cases are likely to be assigned to a team, to this team, for whatever reason. Perhaps they're more experienced, or those cases are just more difficult. And as a result, and those cases are likely to be late and more delayed. So that team is going to have that problem. Now, what I'm typically seeing when in a scenario like this in many organizations is that the assumptions are made, and typically there's consequences for delays or lateness. Perhaps they're personal consequences. And what that does is it's introduces, there's a cost of implementation, there's an effort to introduce it, but it doesn't, because it fails to address the root cause, i.e. the complexity, it fails to deliver improvements in reducing delays and improving on-time delivery. Even worse, it makes people upset because you're punishing them, as it were, for something that's outside their control. You're likely to have a demotivated workforce. That's why it's so important to understand the true root cause and deal with that. And that is what causal process mining does. So causal process mining is a bit like playing detective. And I'd just like to stop for a second and imagine what's your favorite detective program. Many moons ago, I used to enjoy watching Columbo. It's a bit dated and it's a bit battered, but it was interesting watching that show, because whichever detective program you watch, there is one objective, and the objective is to look at a crime, that's a crime scene, gather information through maybe interviewing suspects, CCTV cameras, perhaps phone logs, and then use inductive and deductive reasoning to determine who was responsible. So who was the mastermind? Who was the getaway driver? Who was the lookout? And what's interesting about this is, in this analogy, there are three individuals, but they're not all equally responsible. And it's true that it's in when we look at any problem, as it were, and look at the root causes, there are typically multiple causes, and those causes have varying degrees of influence. Okay, and that's what we're trying to do in causal process mining. So we take our data. It could be in event log format, as we shall see later. It could actually be the raw data, because this transforming into an event log is time and effort intensive. So it could be, we get data, we combine that with the intelligence, human intelligence from subject matter experts and those who know the process, together with causal inference algorithms, and figure out what causes the problem, or what's caused the problem, or what's caused an effect, because effect could also be, we describe it as a problem because it's often a problem, but it could also be a positive effect. It could be, we have higher sales in a certain area. Why is that the case? So what's the problem, or what's the effect, pardon me, and how much did this cause contribute to this effect? So in this case, experience level might be what's causing about a quarter of that effect, the observed effect, and so on and so forth. So what we're going to do now is hand over to Lukas to discuss or show us how Noreja enables causal process mining. So I'll hand over to you, Lukas.
Thanks a lot, Niyi. No, we included, so to say, a small cliffhanger in this webinar because we have two parts. Yeah, the part now, and I will show you now all the base work basically that we have to do for causal process mining, which is the data connection part, and then also the very exciting stuff about finding the root cause and the causal problems will be part of the second part of this webinar. So we will now focus on the data connection, because maybe a few of you also already know that we as Noreja are not using this classical event log. Yeah, we are doing this a little bit different by using graph database technology, and I will give you now a live demo of our tool to give you a perspective on how that works. So let's sign in. And we will skip all the part of dashboards and analyzers and the process representation. As I said, that will be part of the second part of the webinar. We are now diving directly into what we call the builder is. The builder is the part where we connect data sources. And I will now show you basically 3 steps that we have to do to connect a data source to later do this causal process mining. Step 1 is explained in a few words, is basically we have to connect or we have to establish a connection to the source system, the database or an API. Yeah, I won't talk long about this. This is basically boring stuff, entering the connection information, you know, the host, ports, passport, and so on and so forth. As soon as we have that, we have a established connection to a data source. For example, in our case here, a relational database of an ERP system, for example. And now the second part is establishing what we call the entity graph. So the entity graph, you can think of the entity graph basically as a process-oriented representation of your data. So we connect to the source system, and out of the source system we generate a network or a graph of different entities that we later then transfer into process activities. And we do this by building here a new entity. You can build or you can create in Noreja a new entity by selecting the Add button here. You can choose a name. Maybe I can just enter test here. And now you can select the data source that you collected, that you created earlier in the very first step that I explained. This is basically just a connection to a database. Due to the time, obviously, I already created the main parts of the entity, and we will take a look at it. Now we have here this ERP system. This ERP system is called RS2. This is a smaller ERP vendor from Austria, and we will take a look at this entity graph. And what we do here now in the first step is basically we have to tell our tool which kind of data objects, in this case database tables, do we need for our further analysis of causal process mining. Here in this step, you can basically drag and drop these tables into the selected data object set. And as soon as you have all the data sources or the data objects, basically, in this case tables, selected, you have basically the set of tables that you will use as a baseline for causal process mining. So you tell the tool this is the scope of data that we use. If we have that, we can press next. And then we can we come here directly to this step of this entity graph. We call it the entity graph. And this is now exactly this process-oriented view of your data. Of course, also we have AI functionality. So if you enable our AI functionalities, you can later also have the option to generate this entity graph more or less in an automated manner. At least usually 80% of the entity graph, so everything that can be generated by an algorithm. We will now do it in a manual manner to show you how it works, but just maybe as a small theoretical background how that works. It's just a slide that I draw in here, is what the algorithm is doing. We connect to the database, we go into, we look for unique column combinations, we do inclusion dependencies. Afterwards, we look for primary keys, foreign keys, and then we try to detect timestamp attributes and bring that all together in order to automatically generate this entity graph. So just as a quick overview, this is how you can imagine your database looks. We have different tables, and the algorithm is just try to pick out the most important information in order to automate this entity graph in an automatic manner. I will just show you now step by step how we do that manually. So you can see here, we have different entities here, and in the side you can basically drag and drop new entities to this canvas. And in this case, the entity is more or less a database table. So here you can see this is exactly the name of this database table. And now you can choose how you want to transform this data object in a process activity. And for that, with Noreja, we have two possibilities, where I show you again a slide to just show you the different ways. Because in Noreja we can generate what we call horizontal activities. Horizontal activities are basically if you take a table and you use a process activity based on each individual column that you have. So for example, you have a creation timestamp in a column, you have a change timestamp, you have all kinds of business related dates. For example, a delivery date that is part of a column. And you can use each column as an individual process activity. So for example, create the order, change the order, deliver the order. This is then basically 3 activities that you can generate out of this one table. This is what we call a horizontal activity generation. You can also do this in a vertical way. There you just select one column, and in this one column we have different values. quite easy to understand, is a status column where you have the status open, closed, in progress in one vertical column. And then you separate out of each value that you have in a column an individual process activity. And of course, you can also combine these two approaches. But for better understanding, we have the vertical and horizontal way. And I will show you in this entity graph here, which is an order to cash process that is behind it. I can show you just the different ways that we have here. For example, here you have these two entities. You have submit the offer and order received. And you can see in the brackets below that both of these activities are extracted out of the same database table, which is called here 𝐍𝐴𝐽𝐻. And if we now look at the configuration of this activity, you can see here, this is the name of the activity. The activity label basically. You can select a timestamp. Here we have this timestamp, which is called DT Anlag, basically the creation timestamp. And now we separated the activity based on the where clause, basically saying that we take only values out of this table which has the characteristic Auftrag, which is offer, as a value in the column. And here the second activity, which is the same table but a different object, basically, we label it as submit offer. And now we have the same timestamp, but we just differentiate it based on a different criteria that we look, or a different value that we take out of the column as a separator for different activities. This is the vertical approach. And also to show you the other example, we have two other activities here that I can show. These are those two, both out of the same table. This table is called 𝐵𝐵USA. And if I look at the configuration, I see that they have different timestamps. So this timestamp here is 𝐵𝐵USA DTN. This is like a change date. And here in this activity, we have just a different timestamp column. So these are just the two examples for the vertical and the horizontal way of extracting activities. And as soon as you have this entity graph, you are ready to go to the next step, which is the dimension builder. I will show you this in a second. Just an additional thing that we can do with Noreja is, and that plays a lot into what Niyi explained with finding the real cause of a problem, is in Noreja you can add context information to each activity and also on different levels in the tool. And context is basically unstructured knowledge like text, uploading documents. Later we also want to allow that you can talk into it, basically adding contextual information, which is then also stored in a graph database, and you can later, or the AI can later use this context knowledge to help you get to the root cause of your problems. So here in this case it's empty, but it's possible here to enter all kinds of text, maybe test. If you have information here that you can add, that you want to add to your process activity, you can say, I want to store this contextual information in here, and then it is chunked and stored in the graph database. And that is how we in Noreja add contextual information to our processes. Okay, let's delete this thing. So as soon as we established, or let us help establish this entity graph with AI, we can save and exit. And now the entity is built and established. Now the final step that we have to do is we have to build the dimension on top of it. And for that, we click to dimensions. And a dimension, you can basically think about it as a different view or different perspective on the process that is based on the entity graph that you built. This is part of our multi-dimensional process mining approach, is that as soon as you establish this entity graph with all the data in it, you can now query it from all kinds of perspectives based on the different object ID that you choose. So if you want to analyze the business based on the order ID, then you select the order ID as the case ID for this dimension. Or if you want to look at the process from a different angle, for example, by using a user ID as the starting point, then you can select the user ID. So you have multiple dimensions that you can have on your process. If you want to create a new dimension, we also press it here. We can name this new dimension. And now we select the entity graph that we just constructed in the previous step. We create it. Then we can see here we have this new dimension here. We go into configuration, and now we have an identical look and feel to the entity builder. But in this case, we are now having here a list of the activity labels that we set earlier in the entity graph generation. And now here we have again the option to let us generate this via AI, yeah, to let us give us a suggestion of how this dimension could be established based on causal logic of the relationships between the activities. But obviously, of course, we can also do it in a manual way. I'm doing it now, so we can drag and drop here. I'm just picking some activities that make sense. For example, we have order received, and we pick the order items. Then what else can we do? We create a delivery bill, and then later we also send the invoice. It's just a very basic example. And what we now do here is very important because it is one of the bases for the causal process mining is. We allow now the human being to insert causal relationships or relationships where the analyst expects causal behavior. This is probably the best way to phrase it. And now you can basically draw by going here, click and drag and drop, and click here on the pane. You can draw how your causal construct of the process is what you try to later check on. You can also use AI to suggest that, but you can also do it in a manual way, which I did now. What you can also then do is you can open the context menu and add some expected endpoints and, for example, expected start points in the process. You can obviously also choose multiple endpoints or start points. And now the final step to configure this dimension is to set the case identifier, or the dimension key as we call it. This is what I explained earlier. And based on the case identifier that you set here, this will be the starting point for the algorithm to basically do the process mining. So we take, in this case, this simple example here, we take the pick order items, so the picking operations as the case identifier for this dimension. We can also switch it around and say, okay, we want this as a case identifier or the invoice as a case identifier. That is also possible. So we can switch, in this case, the perspectives if we like to do so. And as soon as we have this dimension created, we can say, okay, Noreja, please help us find the causal problems and the potential harmful behavior in the process. We can press next. There are some options that you can take for filtering. It's not important now. We get a summary page, and then in the end, you can press save and exit. Now, where do we have it? We have it here, this new dimension. We have it ready. It's not imported yet. We could import it. I just prepared a fully configured dimension, which is here, the order to cash. Let's take a look in there. And here you can now see, this is just if you have time, if you have more time than just doing it live in a webinar. This is now the full order to cash process modeled in this dimension here. So we really have it from, in this case, submit the offer. So it's even an offer to cash process, so to say, from the offer over the order, prepare the delivery. Then we have the picking operations, create the delivery bill, send the invoice. We have dunning levels here, receive the payment, and then book the receipt. This is the entire causal hypothesis of this process, which will now be the basis for the analysis. So that's it. And now, as soon as we have established this dimension and we have imported it, we can now go into the analysis and into the root cause analysis. I will just highlight it quickly, but as I said before, we will take a deep dive in this in the second part of the webinar. But if we have it and we loaded it, you can see here how the result of the process mining analysis is now generated. And this is the differentiator between other process mining tools, which are based on this directly follow logic, is that you can now see here in red, in red you see all the causal breakpoints in the process already, which could be potential root causes of problems, which are not intended or which are not part of this original hypothesis that I modeled in the previous step in the dimension modeler. So every time the algorithm detects a process instance that is not exactly following the causal logic of the dimension that I modeled earlier, is now directly visualized here as a potential error. potential violation. And in the Noreja tool, you have the opportunity to even select different kind of violation patterns in the sidebar that you can see here. Yeah. So for example, we have the disarray pattern, which means the process was executed in the wrong order. We have the negligence pattern, which means we jumped over a certain step in the process. So we left out an activity that should have been executed. Yeah. So for example, some kind of quality check, which you say could be necessary for this process activity, and we also included it in the dimension. This could be here an overjump in the negligence, or rework, for example, that you can see here. And these kind of causal problems are directly visualized here. But we will dive later into how I can now even use the Noreja AI, which is called Minerva AI, to go in a conversation with the AI and really go deep, take a deep dive into the problems. And we ask, where are the root causes? What are common characteristics of this one violation pattern that I discovered? Yeah? So these are really then the difficult and tough questions that Niyi mentioned earlier when it comes to finding the real root cause of a problem. Yeah, but I think looking at the time, that's already my part. We could now transition into also a Q&A session. If you have some questions, some feedback, or just want to tell us a joke, then feel free to raise your hand and speak up. I'm actually not sure if I have to allow the microphone. Yeah, I think if you can raise your hand if you have a question, and then I can press here on opening up the microphone. Of course, also if you have, I know it's a typical webinar situation where no one wants to ask a question. Of course, always feel free to write us a message afterwards. You can always contact Niyi and myself, and also Lukas, who is in the call here, via LinkedIn or email. And yeah, if there is some interest in taking a deeper dive in that, we have the option, obviously, to contact us directly. Then we have a talk, or you can be part of the second webinar. I'm not sure, Niyi, when we are planning this, but somehow I think after the vacation time, or October, probably something around this time, I guess, September, October.
Yes, that's right. And I was going to give a bit of a context. Can you see my screen?
Not yet, but it's probably building up.
Okay, give me 2 seconds.
Let's wait a second.
Let me share. Give me 2 seconds. Can you see my screen now? You probably will just see. Can you see the slide deck?
Yeah, now it's building up. Yeah.
Okay. All right. Great. Okay. Let me. Okay. Okay. So yeah. So thanks, Lukas. So like you mentioned, we're going to have a second webinar where we're going to see how AI can sit on top of that causal graph and pinpoint not only the true root causes, but also recommend precise interventions, because it's one thing to understand what's gone wrong and why it's gone wrong, but it's another thing to figure out what can you do to actually fix it. So we'll look at that, how that can be how Noreja can help us find that in the next one. And having found out what the intervention means, agentic AI can be used to implement those changes. So we'll look at how, so in other words, it's not what's gone wrong and why is it gone wrong, but what can you do and how can I help you do what you need to do to fix your processes. So we'll fix that. We'll look at that in the second webinar. It's likely going to be sometimes around October Q3, but we'll advise the exact dates. So just to summarize, why Noreja, obviously there are loads of process intelligence tools out there. One, like Lukas mentioned, faster time to discover what you need to do and implement it, because it does not rely on an event log as input. So for those who are familiar with process mining, discovering or preparing your event log can be extremely time consuming. With Noreja, you don't need to do that. Secondly, like we said, you can figure out what the true root cause is, and so what you do is likely to be more effective. Thirdly, it's available as an on-prem solution. So as some of you might be aware, there are a number of process intelligence platforms that are cloud only, and that is a challenge for certain sectors where data privacy, data secrecy is an issue. We know it can have as an on-prem solution. And finally, it is very competitively priced. I know that because I walked across a number of process intelligence platforms, and Noreja is very competitively priced. So do contact us if you want to have a proof of value